Hello, hello. Hello everyone, welcome to Unacademy and Gate Academy Global. So before starting today's session, I would like to have the input as well as the concurrence regarding the quality of video as well as audio. If it has been perfect, just write perfect over the live chat, and then we are going to start the today's session. My dear friend, in last class we had already discussed about the concept of Taylor series and Maclaurin series expansion. If you would like to know or if you would like to recall what was the formula, so let me show you the formula which we had used when we were taking the Taylor series expansion of any of the function around x is equals to a, and similarly at x is equals to 0. That becomes Maclaurin series. So this formula we have already seen earlier. This was the formula which we have already seen earlier. Yeah, this one. You yourself would be able to understand it. So this was the function which had been expanded using the Taylor series expansion around x is equals to a, and the outcome was f of a plus x minus a, f dash a divided by f1 factorial plus x minus a raised to the power of 2, f double dash a divided by f2 factorial, so on and so forth. And same, if the expansion is been made at x is equals to 0, that Taylor series is also been called as a limiting case of a Taylor series, which has been a Maclaurin series. And yes, a is been replaced with 0. What does it actually mean of it? That means the expansion of f of x is being taken around x is equals to 0. Could you understand what I'm saying? So this formula must be there in your mind because the questions are been repeatedly asked from this particular topic. And once you had this formula in your mind, definitely you will be able to crack any kind of problem. So let me go back into the question once again. So here comes the question where it had, yes. Yeah, here it had been. Tell me what must have been the best most answer for this given question. I would like to know from each one of you what must be the best most answer. Anyways, for the each question I would give around 2 minutes. So within that frame of time you had to solve this problem out. Tell me what could have been the best most answer. Your time starts now. Tell me. Your time starts now. Tell me what could have been the best most answer for this given question. The problem states the infinite series 1 plus x square divided by 2 factorial plus x cube divided by 3 factorial, so on and so forth, corresponds to sec of x, e to the power of x, cos of x, and 1 plus sine square of x. 1 plus sine square of x. Tell me what could have been the best most answer for this given question. Tell me. Read the problem carefully and tell me what could have been the best most answer for this given question. Anyways, almost time is up. My dear friend, once you'll focus over this problem, few of the important and critical thing has to be extracted from this given question. According to me, this has not been a complete question. What they had given? An infinite series, and they must have said the infinite series which has been approximated at x is equals to 0 corresponds to. How many of us are been agreeing on my argument? If the student who had already attended my last class definitely would be able to understand what exactly I have been talking about. So this has not been the expansion which would fit the given function in the entire region of x. It would fix only and only at x is equals to 0, and the answer has been e to the power of x. E to the power of x. So Krishanpal Lonkar, did you really understood what exactly I wanted to communicate over here? This has not been a accurate most question, and this has not been a complete question. The infinite series has been clearly given, but this would have also told this has been fit around x is equals to a or x is equals to 0. Agreed? No? So anyways, this would have told this problem in this way. What I am saying, this would have told this problem in this way. The infinite series of this corresponds to, and it has been approximated at x is equals to 0. My dear friend, if the approximation of any kind of function where the successive differentiation has been possible is been taken at x is equals to 0, which has been a Maclaurin series, and we have already seen this has been f of x is equals to f of 0, and then goes x, and then first derivative of the function at x is equals to 0 over 1 factorial, then goes to the power of 2, then goes double derivative at x is equals to 0, 2 factorial, so on and so forth. So on and so forth. So let me start feeding, or let me start calculating the important coefficient which are been the part of f of x, and that has been the worth of the function at x is equals to 0. Anyways, we will see out of a, b, c, d which had been matching it. Let me take the reference of e to the power of x if the f of x is being taken as e to the power of x. So let me take f of x is being taken as e to the power of x. So f of 0 is going to be e to the power of 0, and e to the power of 0 is been 1. Even if we'll take first derivative, no, if we'll take first derivative, e to the power of x remains e to the power of x, and now also we will be feeding e to the power of 0, and that has been 1. And successively, if we'll be taking differentiation and you'll be feeding x is equals to 0, no, the value is not supposed to change. And now many of the students would also have doubts, sir, how did I choose the option B only? My dear friend, see, once you'll see this outcome, no, f of 0 was 1, f dash 0 is been 1, f double dash 0 is been 1, or I should say this has been 1, this data has been followed over here, then this data has been followed over here, and this data has been followed over here. That means I should have a function when I keep x is equals to 0, while its successive differentiation, it must be giving the same value. And that is only and only one function, and that has been e to the power of x. If you'll be keep differentiating e to the power of x, you will find that the slope itself has been matching the function, and that is why the bestmost answer has been B. That is why the bestmost answer has been B. Did you really understood what exactly I wanted to communicate? Now what I am saying, let me show you over the desktop, the things would be clear. So let me switch it up to the desktop. And as it had been already communicated, I will try to teach the things with the graphical methodology, then only the things would be much clearer. And even you can find out this problem is not been a completely accurate question. Completely accurate question. So let me come back. Let me come back to the computer screen and I will try to show you there. Just a minute. I will try to show you there. So let me come back to the computer now. Yes, so here comes. So here comes the screen now. What I would do now, I would take e to the power of x, how it would look like, and then I would also take its approximation with first term, second term, third term, fourth term, so on and so forth. So let me do that. Let me do that. So here comes online graph draw. Yeah. So at very beginning, let me draw y as e to the power of x. Y as e to the power of x. The function must have been over here probably. Exponent function has been here. No, 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 no. E. Okay, let me take e to the power of x. Here comes e to the power of x. Just a minute. E to the power of x. To the power of x. Just a minute, where it had been. E to the power of x. Yeah, e to the power of x. So here comes e to the power of x. So this has been the curve now. This has been the curve. In next step, what I had been doing, I had just been approximated e to the power of x with its constant polynomial, and that has been 1. That has been 1. Yes. Then I had taken the linear polynomial, and that has been 1 plus x. Yes, 1 plus x. What had been happened? Just a minute. 1 plus x. Yeah. And then I take 1 plus x and then x square divided by 2. So here comes 1 plus x, and here goes x square divided by 2. Just a minute. X square divided by 2. X square divided by 2. Divided by 2. And even you can increase the number of terms which are been associated with its running polynomial, and you will be getting the better answer as well. So let me do one thing. I would take the third term as well, and that goes x to the power of 3 divided by 3 factorial, and that has been 6 now. That has been 6 now. You yourself would be able to understand. See, e to the power of x is been this blue curve. You yourself, yeah. E to the power of x has been this blue curve, this blue curve. This has been continuously increasing. Now the red, this is 1. 1 is nothing but its magnitude at x is equal to 0. Yeah, this flat one. Then 1 plus x. 1 plus x is nothing but a straight line passing through x is equals to 0 and y is equals to 1. And approximately it has been approximating e to the power of x at x is equal to 0. And as you take the higher polynomial, what would happen? Now you are been getting better fitting at x is equal to 0. You can see the red one has been better fitting, and even the blue one has been better fitting, that has been upper facing parabola. And now even the red one, that has been cubic polynomial, even has been fitting much better e to the power of x at x is equal to 0 only. What I wanted to communicate over here, my dear friend, what I am saying, can I write e to the power of x as 1 plus x square divided by 2 plus x square divided by x to the power of 3 divided by 3 everywhere for the entire region of x? No, I won't be. I can just approximate around x is equal to 0 only. I can just approximate at x is equal to 0 only. So that is what I am saying. The problem or the questions what they had framed, no, that has not been completely okay. They must have told that the approximation has been made at x is equal to 0. So I would like to know from each one of you, I would like to, just a minute, I would like to know from each one of you whether this problem has been a complete correct problem or still certain improvement has been required. Tell me. So obviously they must have told at x is equal to 0, and there the B must have been the answer. Tell me. So I think the things must be clear to all of us. Yes, no? Okay, then I think it's been the right time. I should also be focusing over the next question as well. So here comes the next question. So here comes the real value of x. Cos of x can be written in the form of convergent series given by, and that has been 1 plus x divided by 1 factorial, 1 plus x, then goes x square divided by 2 factorial plus x to the power of 3 divided by of 3 factorial. Tell me what must have been the best most answer. Yes, sir, clear, no? Yes, Krishnapal, that's what I wanted. That's what I wanted. The same thing they had been asking. See what I am saying. The running polynomial which you had over the options, no, with the help of those running polynomial also you will be able to find whether the approximation has been made at x is equals to 1, 2, 3 or exactly at x is equals to a. My dear friend, the first term used to carry x minus a, the second term carry x minus a raised to the power of 3, 2, and similarly third term carries x minus a to the power of 3. And once you'll focus over all of the 4 options which are being carried out within this problem, no, it has been just x. So virtually speaking, a is being 0. But they must have told about it. What I am saying, they must have told about it. But still the things have been pretty clear that the approximation is being taken at x is equal to 0. So what had been my basic understanding? My basic understanding states all of the running polynomial in this 4 number of options carries the component of only and only x, or I should say if I compare x minus a to the power of n, where used to be 1, 2, 3, it has always been x to the power of n. Virtually speaking, a is being 0. So this is by my basic approximation. This is my basic approximation. At least in this given problem. This has been my basic approximation. At a is equals to 0, the approximation has been made. So what we have been doing, obviously I would suggest to each one of you, you must have a little bit idea about the series expansion of important functions like sine of x, cos of x, e to the power of x, e to the power of minus of x, ln of 1 plus x, ln of 1 minus x. This many important functions which are been periodic and aperiodic both, you must have a little bit idea about its Maclaurin series expansion or the expansion around x is equal to 0. Because once you have that idea, no, definitely you don't have to solve in future. See, what must have been my approach that I am saying. My dear friend, one thing has been quite sure. At x is equals to 0, cos of x becomes 1. So the option which does not become 1 at x is equals to 0 would be discarded. So once the x is being 0 is being fed, no, the c becomes 0 and even d becomes 0. Obviously c and d is being discarded. That is quite sure. And now option A and option B, all of the terms are being positive, and here the terms are being positive and negative. So this is going to be a positive term series. Once we'll be discussing about the series into the great detail, I will definitely discuss about this as well. It has been positive term series. What does it actually mean of it? That means as the value of x would be increasing, no, definitely the worth would be keep increasing. And definitely it can't be oscillating in nature at any cost, because it has been keep increasing. It has been a monotonically increasing. Obviously this has also been discarded, because cos, sine, tan, they have been the oscillatory signal or oscillatory function. So whenever you had an oscillatory function, definitely the polarities would be alternative in nature, plus minus minus plus plus minus. So according to that, the B must have been the answer. Manually, if you would like to calculate each and individual coefficients, and with the help of those coefficients, if you wanted to digest the value of f of x, that also you can do. What we have been doing. So the f of x, which is been cos of x, is to be approximated around x is equals to 0. Around x is equals to 0. Yes, sir. We had to do so. We had to do so. So what we will do? We will calculate the important coefficients, which have been f of 0. F of 0 means straight away the x would be fed as 0. And yes, the value has been simply 1. The value has been simply 1. We will take its first derivative. That is also been required for Maclaurin series. So the differentiation of cos of x leads the value as minus of sine of x. I will feed sine of x, and x has been 0. The worth has been simply 0. The same goes with the double derivative as well. Same goes with the double derivative as well. And that becomes minus of cos of x. Minus has been minus, cos x has been 0. So the worth has been minus of 1. The worth has been minus of 1. And same goes over the successive differentiations. Yes, so here it becomes, just a minute. Here it becomes minus of cos of x. Minus of cos of x is going to be, differentiation of cos would become minus, minus minus becomes plus. So here it becomes, and yes, again the x is being fed as 0. So the worth is been simply 0. If you will be able to recall, the approximation of given f of x around x is equals to 0, which is also being called as a limiting version of Taylor series, Maclaurin series, and that is been f of x is being equals to, the f of 0 is being a first polynomial, and same goes with f dash 0 along with x divided by 1 factorial x square divided by 2 factorial f double dash 0, so on and so forth. So I think it's been the right time I should be feeding the datas as well. So let me start feeding the datas over here. So f of 0 is already been known to be, and that is been 1. Obviously, sir, it has to be 1. F dash s 0 is been 0, so this part has been discarded, and here comes the double derivative, and that is been minus 1. That is been minus 1. So let me do one thing. The minus has been discarded over here. Yeah. What had been the value over here? So here comes f double dash 0 is been minus of 1. Minus is already been out. This has been x square divided by 2 factorial, so on and so forth. So according to that, the B has been the bestmost answer. So the next important conclusion which we can withdraw out of the two questions which we have taken in today's class has been, although they had never told that the approximation has been made at x is equal to 0, but at least once you look over the question, no, few of the things are been clear. What? The running polynomials are being the exponent of x. That means the term which has been involved over this problem has been, no, it is been x minus 0 to the power of n, or I should say approximation has been made. Approximation has been made at x is equal to 0. I could have framed this problem into the much better way. I would write the 4 different options, and I would ask the given series has been approximated along which particular point. And I can understand many of the students may not be able to digest that concept, because they know the process, but they do not actually know the crux behind the Taylor series or Maclaurin series expansion, from where the concept of Taylor series or Maclaurin series expansion has come into the picture. Did you really understood? So I don't find any of the student would have any kind of doubt, at least at this moment of point. Two questions we have already taken. The infinite series, the first question and the second question. Let me go into the third question as well. See what had been happening, my dear friend. The first time the different kind of the questions are being taken, and this question has been experienced in gate electronics, year of 2005. The question was framed by IIT Bombay. Read the problem carefully and tell me what could have been the best most answer over here. Read the problem carefully. This has been the question. The problem states, in a Taylor series expansion of e to the power of x plus sin x, about the point x is equals to pi, the coefficient of x minus pi to the power of 2 is. Here they had not been focusing over the complete series expansion, they had just been focusing over the coefficient of x minus pi to the power of 2, or the multiplier factor of x minus pi to the power of 2. So once you have a Taylor series expansion, you don't have to focus over the all arbitrary coefficient, just go ahead with the multiplier factor of x minus pi to the power of 2 and tell me what could have been the best most answer. Tell me what could have been the best most answer. So I would like to know from each one of you what could have been the best most answer over here. Read the problem carefully and within 1 minute you guys must be able to give the proper most answer for this given question. So here comes the question now. Here comes the question now. Yes. So your timer starts now. Your timer starts now. Read the problem carefully and tell me what could have been the best most answer for this given question. Read the problem carefully. Let me go back into the Taylor series expansion. So in Taylor series expansion, we had an infinite number of terms which have been added. So let's take the function is been f of x is being expanded using the Taylor series. The outcome is supposed to be worth of function at x is equal to 0, then goes x, but here it is not going to be x, no, and even it's not going to be at x is equal to 0 as well, because the expansion is to be made at x is equal to pi. So I can understand this has been the first mistake many of the students would be doing at this point, because we have been more acquainted with the Maclaurin series expansion where the expansion is been made at x is equals to 0, but here we had been doing at x is equals to pi now. We had been doing at x is equals to pi now. So f of x has been expanded around x is equals to pi. So obviously it is going to be f of a. Then goes x minus a, f dash a divided by of 1 factorial. Then goes x minus a raised to the power of 2, double derivative of the function at x is equals to pi, so on and so forth. Rather focusing over the each and individual terminology, you must have focused over the double derivative of the function at x is equal to pi into 2 factorial, and that is what been the requirement of this problem. In this problem, they had just been focusing over the coefficient of x minus pi raised to the power of 2. So now we have been doing so. We had been doing so. See what we will be doing? We'll be taking the double derivative of this function. Let me do so. So here, the first derivative of the function of e to the power of x is e to the power of x, and in second, even the successive differentiation would always lead e to the power of x only. The sine of x differentiation is been cos of x, and again it is been minus of sine of x. It is been minus of sine of x. Agreed? No? Yes, sir. And now f double dash is been known. We had to find this double derivative at x is equals to pi actually. We had to find at x is equals to pi actually. So let me start feeding the data over here. So here it becomes e to the power of pi, and here comes minus of sine pi, and sine of pi, which has been sine of 180 degrees, in degrees actually it has been 0. So the worth is been simply e to the power of pi. So if I say the coefficient of the third term which has been involved in Taylor series, it is been simply e to the power of pi. So what must have been the best most answer? A must have been the best most answer. A must have been the best most answer. In the same sequence, I think it's been the right time. I should also be focusing on the next question as well. Here comes the fourth question. So let me start the timer for this given question and tell me what could have been the best most answer over here. So your timer starts now. Yes, your timer starts now. So I had been just coming out in front of board, and now it's been your turn. Tell me what could have been the best most answer for this given question. It has been a well designed problem where e to the power of minus x has been approximated linearly. What does it mean of linear approximation? That means the polynomial which you are going to use for fitting of e to the power of x would have the highest degree, or the degree has been 1. Tell me what could have been the best most answer. What could have been the best most answer? I would like to know from each one of you. According to you guys, What would be your endorsement? What would be your endorsement? I would like to know from each one of you what would be the best most answer for this given question. Read the problem carefully and tell me what could have been the best most answer. See what had been happening. We had a function e to the power of minus x, obviously, which has been exponentially decaying in nature, and the approximation is to be made at x is equals to 2. That means the value of a is being 2, where the approximation of e to the power of x is to be made using a running polynomial. Agreed? So what we have been doing over here, obviously we will recall the Taylor series expansion of the given function f of x, that is been e to the power of minus x, and that to around x is equals to a, where the a is been 2 over here. We have already seen if you wanted to fit a Taylor series expansion over any kind of function f of x which has been a continuously derivative at a certain point x is equals to a, could have been written as the worth of the function at x is equals to a, that is been f of a, and here comes plus x minus of a, the first derivative of the function at x is equals to a, or the point where around the approximation is to be taken. Then this keep moves for the higher degrees, and that is been the case now. That is been the case now. Yes, this has been the case now. This has been the case now. Let me start feeding the datas. Here in this problem, this has been clearly said that the approximation has to be linear in nature. What does it actually mean of it? The running polynomial which you carry, they should not have the degrees of 2 and more than 2. My dear friend, if we had just taken the starting 2 term where the highest degree which this given function carries is been 1, it is being called as a linear approximation. If the highest degree is being 2, it is called as parabolic approximation or the second degree approximation. Similarly, if the three number of terms are been connected, or I should say the power of x is been raised to the 3, it is also being called as a cubic approximation. We had already seen with the help of graphical approach that as the number of terms, as the number of polynomials increases, the approximation would become better and better, or I would say the truncation error would be continuously decreasing in nature. We had already seen about it. So I think this is nothing great, nothing new. We had to call upon only and only this starting 2 terms. So let me do so. So we had just been focusing over starting this 2 term. What I am saying in this problem, this has been clearly said. The starting 2 term is to be considered. So we had to focus over the coefficient f of a and f dash a. So let me focus over this 2 terminologies. So here comes f of a and then comes f dash a. F of a and f dash a. E to the power of minus x, that has been function, x has been replaced with a, and where the value of a has been pi, not pi actually, 2 actually, 2. So here comes e to the power of minus 2, e to the power of minus 2, that is quite okay, sir. Then we will be taking its double derivative, and once we will take its double derivative, it is been minus times of e to the power of minus x. And now again I will feed the x as 2. So here it is been minus of e to the power of minus 2. We'll just feed this value and we'll try to get what's been the best most answer. So what we have been doing over here, let me focus over in this point. This one, no? This one. I have been just been focusing over here. So f of a is already been known, and that is been e to the power of minus 2. Yes, e to the power of minus 2. And then comes plus 1 factorial can be discarded, that has been 1, and the division of any of the number or any of the function with 1 remains the same function. So obviously it had been x minus of 2 raised to the power of 1, raised to the power of 1. Yes, just a minute, raised to the power of 1, and here comes e to the power of minus 2. Here comes e to the power of minus 2, and minus sign is also been there. So what I would do over here, this would be discarded actually. Yeah, so here comes this. Here comes this. What I would do, e to the power of minus 2 is been a common factor. So I will take out and we'll get this answer. We'll get this answer. Tell me what could have been the best most answer over here. So yes, this has been e to the power of minus 2. That has been 1 minus of x plus of 2. So the result is simply going to be 3 minus of x e to the power of minus 2. Yes. This has been the linear approximation of this function e to the power of minus x. E to the power of minus x. This has been the linear approximation. And that too at x is equals to what? X is equals to 2. Let me show you over the computer once again. So let me go back. Let me go back to the screen and I will try to explain the thing into the better way. The same thing has been happening again. I would take a plot. The plot is been for e to the power of minus x. E to the power of minus x. What I am saying, the plot is been for e to the power of minus x. This has been the plot. Let me cancel the remaining plots. And the linear approximation which we had taken over here, you yourself would be able to see over here. It's been 3 minus of x. It is been, just a minute. It has been 3 minus of x. Let me copy this down. So it has been 3 minus of x. Here comes 3 minus of x. And then goes e to the power of, here comes e to the power of, and here goes minus of 2. Minus of 2. So I would like to know from each one of you whether the e to the power of minus x has been approximated. Yes, it's been approximated, but where the actual approximation has been made, you yourself would be able to say this has been the point where the given function e to the power of minus x can be approximated by a straight line. I could say this as a linear polynomial, but it is being made at x is equals to 2 only. If you'll say, sir, this has been a linear approximation of e to the power of minus x entire region of x. No, there had been quite a big difference, as you can see. Once you go towards left hand side, there had been a huge difference between this blue curve, which stands for e to the power of minus x, and this red curve, which has been a linear approximation of e to the power of minus x. So can I say this linear approximated curve has been approximating this given e to the power of minus of x function everywhere in entire region of x? No, it is just been approximating around x is equals to 0 only. Around x is equals to 0 only. So that is been the crux behind this problem. Agreed? No? So that looks okay. That looks okay. No issue as such. That looks okay. No issue as such. So let me come back to the camera once again. At least I would request to each one of you, keep giving the feedback, because even I want the feedback whether you guys have been grasping the things or not, which has been very necessary for me. And if the crowd would not increase over the period of time, even I need to shut this down maybe in next 2 to 3 days. That solely depends that you guys have been maintaining the crowd over here. Now again, the Taylor series expansion of 3 sin x plus of 2 cos x is. Taylor series expansion of 3 sin x plus 2 cos x has been. Tell me what could have been the best most answer for this given question. I would request to each one of you which topic I should start after this. Should I be using or should I be teaching the probability? So at least this input must come from you guys. Tell me what could have been the next topic which we can learn from here onwards. Read this problem carefully and tell me what could have been the best most answer. Let me start the timer now. So let me start the timer over here. So here it starts the timer. Tell me, what must have been the best most answer for this given question? I would like to know from each one of you. I would like to know from each one of you what must have been the best most answer. I would request to each one of you, tell me what could have been the best most answer for this given question. The 2 minutes is been allocated to you guys. Within 2 minutes, you must be able to crack this problem out. Let me start this timer once again, but I want at least 2 or 3 number of inputs. So let me start the timer once again. So the timer has been started once again. Focus over the problem. I had just been came out in front of the digital board. So focus over this question and tell me what could have been the best most answer for this given question. So as per the Paul Lonkar, the answer is supposed to be A. Let me focus over this question. Anyways, again, once you'll focus over this problem, the running polynomial is being expanded taking the reference of x. You can see very well it has been x square, x to the power of 3. That means the reference around which the complete expansion has been made is around at x is equals to 0. So either you can call it Taylor series, which has been expanded at x is equals to 0. Even you can call this as a Maclaurin series as well. Could you really understood what had been happening so far? So at least by watching the options, you will be able to understand where the expansion has been made. Obviously, the expansion has been made at x is equals to 0. So what I am saying, once you'll focus over the each and individual terminologies, the expansion is being made at x is equals to 0. Expansion. Expansion is being made at x is equals to 0 actually. It's been made at x is equals to 0. Agreed? And I expect the expansion of sine of x and cos of x must be known to all of us. If it is not been known, I would request to each one of you have a look of all of the important functions expansion at least at x is equals to 0, which includes e to the power of x, e to the power of minus x, cos x, sin x, ln of 1 plus s, ln of 1 minus x. So yes, it has been 3. Sine of x is going to be, this is going to be x, and as it is been an oscillating signal, obviously the terminologies or the terms are going to be alternating in nature, plus minus plus minus. So here comes 3 factorial, then goes x to the power of 5 divided by 5 factorial. Anyways, it would have an infinite many number of terms. I am not going behind each and every one. And then comes plus of 2 times of, here it starts with 1 and then goes x square 2 factorial, then comes x to the power of 4 actually, x to the power of 4 and divided by a 4 factorial, and this terminology keep goes on. What I would do, I would just multiply it with 3 and x, and that is being just 2. Anyways, with the help of these 2 terms itself, I could have got the answer as well. Why? Because the constant term is not going to change anymore, and even the first degree term which has been present over this system is not going to change anymore. So may I know what is going to be the best most answer? Either you could have gone against the C or A. The B and D is already been ruled out. Anyways, minus x square, just you have to focus over the part of cube actually. You don't have to focus over the x square. Why? Because x square has been same in option A and option C. Anyways, option A and option C also can be seen. So you yourself would be able to understand the 2 and 2 factorial goes off, and here the value is simply going to be minus of x square. So may I know what had been the best most answer? A has been the best most answer. A has been the best most answer. Did you really understood what I had been telling? I would request to each one of you maintain the crowd over the live session. Otherwise, in future, wantedly or unwantedly, I may need to close this series in future, because I had to also show that the students are been interested watching this live session. So here comes the infinite series again, x minus of x cube divided by 3 factorial, so on and so forth, converges to. See, convergence and divergence has been a very, very important topic which we'll be learning in future. But for the time being, let me focus over this problem. Don't focus on the convergence. Just try to understand in this way. For the given function f of x, which is being approximated at x is equals to 0, would be equals to of which kind of function? So obviously, it is being option A. Option A has been the best most answer. Option A has been the best most answer. Here comes the option, question number 7. It is a quite interesting question. It is not very difficult, but yes, many of the students might find this problem a bit difficult in compare with the questions which we had taken in today's class. So let me do one thing. Let me start the timer for this given question and tell me what could have been the best most answer for this given question. I would like to have the input from each one of you. Tell me what could have been the best most answer for this given question. Tell me what would be the best most answer for this given question. So let me start the timer once again. For this question, I may give 2 minutes as well. No issue. Read the problem carefully and tell me what could have been the best most answer. Nobody had given an answer for this question. See, what's the basic mistake you must have done over here? What you could have done? Probably most of the student would take sine of x divided by x minus of pi as a function f of x, and they would take its successive differentiation, and that's a mistake where you guys must be doing it. See what happened. The differentiation of sine of x has been quite easy, but the differentiation of sine of x along with x minus of pi at denominator would become quite difficult. And once you focus over the options, now you yourself would be able to understand the expansion is being made at x is equals to pi. So what we can do, x minus of pi can be kept as it is. I would expand sine of x with respect to the running polynomial of x minus of pi, or with respect to the approximation at x is equals to pi. So what I would be doing, I would just been focusing over where yeah, here comes, yes. So here I would keep sine of x minus of pi, rather expanding the complete function. X minus of pi would remain common with all of the terms which are been present over the running polynomial, that remains common. And here comes f of a. Yes, I may write this. F of a, the value of a is been pi, and then comes plus. Here it becomes f dash a x minus of pi divided by of 1 factorial. Then goes f double dash pi x minus of pi raised to the power of 2 divided by of 2 factorial, and this term goes on. This term goes on. So yes, f of pi. The value of f is been sine. Sine of pi is been 0. So at least the term which has been x constant is not been there. Yes. What had been happened here? Just a minute. Sine of pi is been 0 na. Anyways, let me see that. That has been 0. If we'll take its first derivative, the first derivative of the sine of x has been cos of x. Now similarly x has to be fed as pi. So cos of pi has been minus of 1. So obviously I may rule this out. So it has been minus of 1. It has been x minus of pi. Yes. Anyways, the same thing is going to happen over here as well. Once you subtract it, it is going to be minus of 1. And similarly, the next term which we are going to add, it has been x minus of pi to the power of 2 divided by 3 factorial. To the power of 2 divided by 3 factorial. And from here, easily you will be able to crack this problem out. So what had been the best most answer? The D has been the best most answer. D has been the best most answer. Yes. Best most answer. I would request to each one of you, the student who have been from electronic side, this would also follow me over the next lecture which we are going to have on our main channel 9 o'clock. And at the same time, I had also been taking the special class in daily basis on our Unacademy platform. So there the topic which I am going to take in tomorrow's class is going to be scattering parameter. Definitely you will learn and you will like that topic. Till then, bye bye. Take care.